Welcome to From Code to Cloud, streamlining your development workflow. My name is Jihei. I'm Customer Success Engineer at Microsoft. I have a lot of cool and interesting information to share with you today.
Hello, everyone. Thanks for joining in this session. My name is Justin from Microsoft as a cloud advocate. Back in 10 years ago, I was a backend API developer. I joined a company in Australia, which was a leading company in their industry. They are still the leader of that industry. I recall that at that time, their change management process took 2 weeks, regardless it was big or small. Their backend API was built in ASP.NET. I think that anyone in this session who is familiar with ASP.NET applications, this screenshot might also look familiar. This was a production environment. We only needed one web.config file, but there were so many other backup files in the same folder. This was because before the production deployment, developers had to back up the configuration files and binaries, just in case for the rollback. If something happened, they copied the old files back from the backup directory and configurations as a rollback process. Many of us might laugh at this process, but this still happens at many companies. We keep deploying applications in this way. Can we call it as a continuous deployment? Well, let's call it as continuous manual deployment. There are many issues on this manual deployment process. One of the issues was that it took too much time to deploy applications to all the production environment. So every developer in the company asked the same question to each other, whether we could minimize the time for deployment. But unfortunately, no one wanted to bear the cat. As no one wanted to do so, I just wrote a very simple PowerShell script. It only automated the process when we did it manually, such as create a backup, copy files from the developer's dev machine to the production. That sounds funny. Remove the backup files from the production and roll back if necessary. It does nothing fancy, but it did its job. Before we applied the PowerShell script, the original manual deployment process took around 2 hours, from deployment, testing, and finalization. But after applying this simple PowerShell script, the overall deployment time, including manual testing, went down to 20 minutes. The script file was not that special, as I mentioned. It just changed developers' behavior, but it has improved the huge productivity increase. I don't think this is the only issue from that company, but many of us might still be having a similar experiences nowadays, even if it's 2020. Comparing to this story, how's the organization? Let me introduce Jihei to discuss further.
Thanks, Justin. As he pointed out, this could still be an issue and reality for a lot of us here today. Deployment could be one thing, but there are so much more things game developers have to do. In an ideal world, of course, it would be great if game developers could spend most of their time on writing code. This is especially important because when it comes to games, users' expectations have never been higher. Quality of content has increased exponentially. Also, games are more immersive than ever. So we're living in the era where the key to win the market is to ship quality apps faster and more often. If we want to build a new game, then where do we begin? Let's take a look at the idea of a standard product lifecycle leading up to a new release. Unfortunately, we don't get to jump into building a game immediately. First, we need to pencil down requirements, preparing specs, and finalizing the design. Once the plan is all set, we can finally start building a game. Then are we done now? Nope, of course not. We're not done yet. In fact, the real significant overhead begins now. We need a machine ready to build and test your code. Not to mention the maintenance cost, keeping it up to date is a big hassle. Maintaining work is not fun, consumes a lot of time and efforts, and creates a low business value. Also, distributing your game to app stores is often a manual process with a lot of details. Some studios have built their own servers to manage different release versions and distribute the download link to beta testers or app stores. On top of it, unforeseen circumstances can get in the way, which derail your project and cause delays. For example, this could be networking issues, design and implementation taking longer, or quality issues or finding and fixing bugs, and etc. Then you're starting from fixing the code again. The end result is an unexpected release date further into the future than expected. Even after successfully polishing the game, it is crucial to monitor your game's stability in production, gathering stack traces, crash attachments, and event breadcrumbs to diagnose bugs. So, these are not optional steps anymore. This is the only reliable way to make your game better. Just a short while ago, this process would be daunting for even the largest teams. So, how could this be something that every developer does on a daily basis? So, the idea of automating dev cycle was introduced. In a nice word, we call it DevOps. Some of you might be familiar with this meme. People were thrilled, excited, and shouted with joy. But soon after, this became our reality where we're facing lots of tooling complexity. This is not what we planned in the beginning. Of course, we need to balance between simplicity and variety. Let's think about a better way and start again. There are many DevOps engineers out there. This certainly is not something new to many developers. However, the performance and outcome can be varied. According to a DevOps report by Dora last year, DevOps enables some top performers to ship more than 200 code deployments, 106 times faster than before. Also, it dramatically reduced incident management time more than 2,000 times faster and built a more reliable production. The goal of this session is to enable you to become elite DevOps performers and achieve the same thing. We want to walk you through a virtual company called dinkum on what we could offer to improve their DevOps workflows from 3 different perspectives in the next slide. Okay, as I mentioned, we're going to break it into 3 different topics from development, deliver, and monitor using GitHub and Microsoft Game Stack.
Right. As many of us know, GitHub is the #1 developers platform for the application development. Do you agree with that? I'm pretty sure most of us in this session agree with this statement. If there is anyone who hasn't used GitHub before, I would highly recommend using it right after this session. It's completely free for open source project. As GitHub was merged by Microsoft 3 years ago, GitHub has now full support by Azure. In other words, if we use Microsoft Azure for GitHub, with GitHub, there are more chances to increase your business values. Let's start with the development perspective. How can we leverage GitHub and Azure for your better development experiences? dinkum has already had their build automation, although they have been using it, the state-of-the-art continuous build pipelines, they thought is too complicated. How can we help them simplify their CI or continuous integration workflows? Yes, we are going to talk about GitHub Actions to simplify the build automation. Each GitHub repository offers GitHub Actions. This has a significant meaning for developers. Right. First of all, GitHub Actions, of course, is fully integrated with GitHub repository. Let me give you an example. You probably use your own build server running separately. Although the build workflow definition lives in the repository, the build activity itself takes place outside the repository, which is the build server. All right, one question arises here. Why do we transfer our code base to the separate build server, which we should care about? With GitHub Actions, we don't have to leave the repository. In other words, our code base and build stay within the same repository. As I mentioned here, with fully integrated GitHub Actions, we build on every commit without having to leave the GitHub repository. GitHub Actions provide us with built-in build agent called Runner. It gives us huge benefits that we don't need to maintain our own build server. If we give up the build server maintenance, we focus more onto our code base, which will result in increasing our business values. Those built-in runners support multiple platforms, including Linux, macOS, and Windows. Therefore, we can build applications on any platform. Of course, GitHub Actions provide us with the option to choose our own self-hosted runner. Most build activities can be covered by GitHub hosted runners, but sometimes we need our organization-specific tools to be installed. In this case, we can choose the self-hosted runner option. Alternatively, some organizations prefer to running their application build within their network because of their security reasons. In this case, we can also choose the self-hosted run option. GitHub Actions is triggered by any event raised from the GitHub repository. Events can be anything, such as code push, pull request, issue created, comment, etc. Event source is not the only from inside the GitHub repository, but also can be from outside the repository. We will talk about this later. If you are familiar with serverless technology, you feel that the way of how GitHub Actions work looks pretty much like it. Let me give you an example. We don't have to worry about the runner infrastructure by using GitHub hosted runners. Also, every GitHub Actions is triggered by an event. If you use GitHub Actions for open source projects, it's completely free. For the private repositories, it's free for the first 2,000 minutes. Then you can pay as you use. One of the best bits of GitHub Actions is that everything is open source and can be connected to each other. Any individual developer from the community can contribute to actions, which makes GitHub Actions real powerful. Here are just a few examples of the community contributions. You can find them at the marketplace. Someone might ask a question. Should we only use Azure because GitHub is now backed by Microsoft? Well, actually, it's not true. Although GitHub Actions is powered by Microsoft Azure, it can interact with any other cloud services like Amazon, Google, and so on, as long as they provide actions. It doesn't also restrict programming languages nor platforms. Anything can happen via GitHub Actions. To minimize build effort, GitHub Actions offers the matrix build capability. As you can see the screenshot, we can set up the matrix with a few parameters. Then the build will be running as many times as the combination of the parameters. According to the screenshot, we only define one workflow, but it will run 8 times with different combinations of Unity versions and target platforms. For this matrix build, we don't need anything but the workflow definition. This is one of the powerful features of GitHub Actions. All right, let's take a look at the short video that I took. It will show you how the GitHub Actions work. All right, let's have a look at this workflow. The first one is the event. So this workflow is reacted by the push event. Then the second highlight bit is the matrix definition. So we are going to use one Unity version, and we are going to target 2 different platforms, which is Mac and Windows now. So the final combination will be 2. Now, this bit is we are going to check out the code base from the repository. Then, in order to get all the secret values from the Azure keyboard, we should log into Azure and get all the secret values. And this part is the core of this workflow. We are going to build Unity applications based on the combinations of the matrix parameters. Once it's done, then we are going to zip all the artifacts there, and finally upload this artifact for the next job to consume. So this is how the build workflow is defined. Okay, so let's commit this change and see how the actions is actually triggered. So when we click the actions tab, and it will show the actual workflow is running. So see the yellow dot, which indicates the workflow is now running. And as I mentioned before, the combination of matrix is 2. So the first one is targeting the Mac OS with this Unity version. And the second workflow is targeting the Windows version with this Unity, right? So we only define one workflow, but within that workflow, we use the matrix definition so that the 2 different build happens at the same time. Now we are seeing the Unity build application, the process. So this action is actually using the Docker container, and all the code base is running within the Docker container. Then, yeah, all the build is finished now.
All right, thanks, Justin. Let's move on to the distribution phase. I'll walk you through how we can leverage Azure Blob Storage and App Center to enhance your distribution experience. Verticom desires to automate their distribution pipeline. So far, distributing the release to QA team is all manual works. How can we reduce their time and effort to publish a game to production? Games are not shipped one and done anymore. We're continually making updates, improvements, and fixing issues. You need the ability to rapidly go from new feature or identifying a bug to implementation and shipped release in less time than ever. Star ratings in today's world, one bad release can really slow down the adoption of your game. Write DevOps tools that enable team to build, test, and ship their updates multiple times in a day significantly reduces R&D costs by narrowing a team's focus to game development. Publishing to Google Beta or Test Flight gives the ability to test out your game to players around the world before making it available for everyone. Using App Center distribution, you can automate distribution pipeline to app stores and your own QA team. Or you can also publish your build artifacts to Azure Blob Storage. In the following demo, we're going to show you the versioning system built in Azure Blob Storage. So in the previous demo Justin showed us, we built a Unity game using GitHub Actions. The build artifacts are in ready to be shared with the dinkum's QA team, which we haven't done yet. In this demo, we're going to show you how to release it to Azure Blob storage automatically and manage different versions. So let's take a look at the short video. Let's go back to the GitHub Actions we have. Here you can see the part that publish build artifacts. What we're going to publish is a compressed file in the earlier job. This was uploaded to the runner to be used in the next job. First, we need to update the build number in this part and download the artifact that we updated to the runner. Once it's done, let's scroll down a little bit to check the part that handles security information. So using Azure Key Vault, we're going to publish the build artifact to Azure Blob storage with this command. Okay, then let's scroll up back again to see the result in Actions tab. If you click the workflow, as you can see, the publishing job was executed. I'm going to expand the section where we updated the build number from 5 to 6. Here, as you can see, it's 6. And then, if we expand the publish artifacts section, you can see the version 6 Windows here. And then macOS apps are created using matrix builds. Let's take a look at the Azure Blob storage. In the Explorer, I'm going to hit the refresh button on the top to make sure we're seeing the latest status. The folder for the latest build number 6 is sitting here, and you can check both macOS and Windows apps. So far, we automated our build and distribution cycle. However, there was no further control when publishing a new release. In fact, over the years, we learned our lesson after talking to numerous game studios and enterprise customers about the importance of approval gates and deployment controls. Let's say dinkum asks for this additional step. Now we're going to explain what are possible options to achieve this goal. Unfortunately, GitHub doesn't provide a built-in feature for approval gates as of now. However, approval gates can be built using custom actions powered by community. If your main communication platform is Slack or Microsoft Teams, you can connect it to GitHub Workflow easily using custom actions that are available in the marketplace. This means whenever a new release comes out, it can give a notification to your communication channel asking for permission prior to deployment. We're going to show you the automated distribution phase with an additional control here using Microsoft Teams. In this demo, GitHub Actions will notify Microsoft Teams of a new release and pops up a new button in the channel for an approval. Once a release is approved, this will trigger a job to send the build artifacts to QA team. Let's take a look at the short video. We're back to the YAML file here again. Here you can find the section that sends a message to Microsoft Teams asking for permission. Let's go to the Actions tab to check the executed result. In the publishing stage, if I expand the section that I just showed you in the YAML file, you can see the command was successfully executed, and you can check all the details about it here in this part. The new message in the Teams channel say, the build version 6 is published to Azure Blob storage, asking for the permission to deploy to production. If you approve this latest version and click the button, a new message appears in the thread. This is a pretty nice interaction. There you go. This will trigger a new workflow in GitHub to release it to production using App Center distribution. Let's go back to the Actions tab to see this. Here you can see 2 jobs in progress. If I expand the first job, it shows they're building a macOS app and distributing it to App Center. The second part shows a building phase for a Windows app. Shortly after the build is completed, the new job to distribute it to App Center starts. Once the distribution job is completed, it also sends a message to Microsoft Teams to notify. On the right bottom of the screen, you can see the new message is available in Microsoft Teams. The message says, Windows and Mac OS builds with build number 6 are released to your QA team using App Center distribution. On the left, I'll show you the App Center portal where you can track all release history. Here you go. It says version 6 is published to your QA team just now.
Right. We have looked at both development and delivery perspectives. Once our application is distributed, what should we do as a part of the application lifecycle management? That's right. We should keep monitoring whether the application is healthy enough. If something happens while using the application, we proactively check the potential issues and manage them. Fair Dinkum asks this question, whether we can proactively monitor app health and log issues onto GitHub. There are many ways to achieve this, but in this session, we will use Azure Integration Services. We distributed the application to App Center. While using the application, if the app crashes or throws the exceptions, App Center captures them and raises events. Those events can be captured by Azure Serverless product and services, such as Azure Functions, Logic Apps, or Event Grid. If your application is integrated with PlayFab, that's also fine. PlayFab also raises richer event payload so that Azure Functions or Logic Apps or Event Grid can capture them. As you can see the screenshot, we register a webhook event on App Center that is connected to Azure Functions. By doing so, when a crash event occurs, the Azure Functions endpoint captures it and creates an issue on GitHub. So, how does the event raised by App Center create an issue on GitHub? App Center is the event publisher, as is the source of the event. GitHub is the event subscriber because it consumes the event. However, the source event format from App Center is not the one GitHub can understand. Therefore, we need an interface to convert the format from one to another. It's called the event handler. As a function is one type of event handler. It captures the webhook event from App Center and converts the event data for GitHub issue. This will be the simplest form of the event handler. But sometimes we need some more complex logic to handle the event messages. If the complex logic requires workflow orchestrations, Logic App would be the right choice. On top of that, if the event messages are mission critical, which means we should not lose any of event messages, Event Grid could be the best fit, as it supports dead letter queuing and retrans. However, Event Grid can't be used by itself. It should be combined with other services like Azure Functions or Logic Apps. With these Azure services like Azure Functions, Logic Apps, and Event Grid, we can easily convert the event webhook from App Center to GitHub issues with much more reliability. All right, in this demo, I will show you how we can capture the crash event through App Center, pass it to Azure Functions, and create an issue onto GitHub. Right, this is the demo screen. The right-hand side is App Center, and the left-hand side is the GitHub issue board. So currently there is no GitHub issue at the moment. Now, on the right-hand side, I'm going to click any of these the app So just I'm using the back app here and check the settings here. And as you can see, there is a webhooks in here. And webhook is the event raiser. So click this event. So in here, this is only responsible for the crash event, right? And when the crash event happens, the crash event data is sent to the Azure Functions endpoint like this, right? So what that means is when the application crashes, then that crash event is captured by App Center, and App Center sends that event, the crash event and message data to the Azure Functions. Then Azure Functions handle the data and create an issue onto the GitHub side on the left-hand side, right? So we are not going to use the real application. Instead, we are using the test webhook in here. So I'm just click the test webhook, and oops, it takes time. Yep. So what it says is test successful. So the application, the Azure Functions captures that event. Now it has been processed. I believe. Now when we refresh the GitHub issue, okay. So 17 seconds ago, the event is captured and issue was created on the GitHub board. So what that means is this. Now we can see is that this is just test payload, but in the real world situation, that the crash event report will be more meaningful.
Now, we have talked a lot about DevOps and how you can use tools to automate aspects of your development lifecycle and improve development with your game. This is just a beginning. Azure and GitHub offer a number of services you can leverage to take things even further. We're only at the beginning of the journey with you, and we want to be your partner in creating great games for your players to enjoy. Not only do you get the most productive developer and DevOps tools and platforms with GitHub and Microsoft Azure, but because these are integrated with Microsoft Azure, you can deploy to and take advantage of more than 100 services that we have for your use. This is not a complete listing of all services, but highlights some of the key and main areas that you can utilize to accelerate your innovation. You can deploy to our core infrastructure or advanced platform as service workloads, such as Azure Functions and Azure Kubernetes Service. Also, you can leverage Microsoft and open source data solutions, AI, and cognitive services, as well as extending your application across Azure Stack and hybrid deployments. We have introduced how Microsoft Azure can improve your workflow and create more business values. If you want to learn more about Azure, Microsoft Learn is a great starting point. It's completely free, and you don't even need an account for this. Here in this slide, we only show the links about Microsoft Learn in general and monitoring, but there are other topics as well as like serverless, infrastructure, and so forth to enhance your development experiences. Also, GitHub has its own learning lab. Through GitHub Learning Lab, you can learn how to make use of GitHub Actions and others. I highly recommend checking out GitHub Universe workshops, where you can master GitHub Actions and learn how to integrate DevOps principles into your workflows. We also have courses that guide you on how to migrate your repository to GitHub and secure your workflow with best practices. If you're interested in learning different programming languages, you can also check out the introductory sessions for Node with Express, Python, Ruby, and stuff. Also, GitHub is working on new solutions and features to meet enterprise customers' needs, so please make sure to stay in tune with us. So this is the end of our story. However, as we mentioned, this is just the beginning. Now it's your turn to show off your great works. We look forward to hearing your own stories with GitHub Actions and Microsoft Azure.
Okay, thank you so much for joining our sessions today. Please feel free to reach out to Jihae or myself on social media if you have any questions. We are always happy to help. Thank you, everyone.
Thank you.
Bye.